So 11.6 and 11.5, I mean, I think here we're just, the math's pretty much the same, but we're just looking at maybe some nuances in how we express the hypotheses. If you read 5, it says women's height's a suspected factor for difficult deliveries. That's shorter women are more likely to have cesarean sections. A medical researcher found in a sample of 45 women who had a normal delivery, so we got our N1, that's our first sample. Let's put our information down as we're going through it. The sample size is 45, that their mean height was 61.4, so our X sub 1 mean is 61.4. A second sample of 39 women, so our N sub 2 is 39, right? Who had a cesarean section had a mean height of 60.6 inches. Okay, so we put in that mean, and then it gives us our standard deviations, and it says, let's see, assume that the population of heights of normal deliveries has a population standard deviation. Okay, so our first one was the normal delivery, so our standard deviation sub 1 is 1.2, and our standard deviation sub 2, then if you read further, is 1.1 inches. Okay, and then we have to state, because you got to read this one, it's a little bit tough. Let's see, so are those who had cesarean sections shorter? Okay, and use the 0.05 significance level, find the p-value, etc. So I remember our cesareans were the X sub 2, or the mean, second mean, right, in the second sample and everything. So I want to know if these ones were shorter, but that's my mu2, right? This is my mu2 here. And so, but I always put mu1 first. Well, how do I do that? Then I just do it kind of backwards, and I say in my alternate hypotheses is mu1 greater than mu2. That's the same as saying, right, that mu2 is less than mu1, and so then my null hypothesis has to be just the opposite, that mu1 is less than or equal to mu2. It always gets confusing though when it's time to do it. So okay, so do the math, and it's our same formula here. We have to find our z. It's the 95%, you know, so again the z is going to be, I got 1.65 here, it could be 1.645 or probably 1.64. wouldn't be incorrect either, and I'm going to reject it though if it's greater than, right, if it's greater than 1.65. so I do all my math, and I come up with a z value of 3.18. So it is in fact, okay, greater than. So I'm going to reject the null. I'm going to reject this first one, and I'm going to accept the second one. Then I'm going to accept my alternate hypothesis, which is that mu1, or that my normal deliveries are in fact taller than mu2. Okay, it's reasonable to conclude that shorter women have more cesarean sections, or that my mu2, my cesareans, right, are, okay, smaller, shorter than my mu1. And when I calculate my p-value, by the way, on that 3.18, you know, and how, I mean, why do I say it's virtually zero? Because you can just come out here, right? I got to go to a z of 3. Will it even go that far? Yeah, right there, right? 3.17, 3.1, somewhere is in about there, right there, huh? 49.9. So my p is, since it's a one-tailed test, is 0.0, actually it'd be 0.0007, right, or 0.07%. So it certainly affirms then it's reasonable to conclude that shorter women have more cesarean, and the p-value is nearly zero, which makes that, you know, an absolute certainty in that case.